hi there! Oh, the music is playing. Hi there! Hi, hello everyone, welcome to another stream. Hi there, Remco. Hi, the Siphon. And what a phenomenal timing, because why do we divide the fundamental force, right? Isn't that bizarre? Isn't that at least a bit bizarre that we divide electromagnetism into electricity and magnetism? I don't know, to me it always felt weird. But there is a reason. Hopefully, at least. I mean, I have one reason why we would divide it. It's just I need to confirm it. That reason being history. Hi there everyone, how you all doing on this fine day? Hold on, let me just play some music. There we go, there we go. I almost remember everything. I remember about the fundraiser, I remember about the thumbnail, I remembered about everything except for the music. Funny, because I'm studying tensorial electromagnetic fields. How convenient, Remco! Oh my goodness, how convenient. Because today we will be doing mostly well, we'll be obviously having an animation render in the background, because, you know, it's just, I gotta save time, am I right? But also, I will be trying to figure this out, to be completely honest. Oh, that's wild music. So, here's the thing. Let me turn off everything that's not related to the video. And then here we are. So, I've been working the video some more. I've reached the point where I'm trying to explain what photons are, as in why wave-particle duality is actually kind of obvious when you think about it. Or rather, not obvious, only why it shouldn't be confusing, only makes sense. Oh, there we go. That's a much better way to put it. The reason is probably because it is easy to understand electromagnetic fields when you are beginning to study physics. That's exactly the reason that I came across. Well, for me, the reason seemed to be historical. So, like, historically, we had magnetism and we had electricity, and we had no idea that both of them stem from the same fundamental force. Because, like, if you think about it, then there is no electricity. This should just be like magnetism, and then there is also magnetism when it's moving. It's not like there's really... The electricity of electromagnetism is more like a historical thing than anything else. There's always going to be magnetism. Although there's one thing that's annoying, because there's one thing that's kind of stopping me at the moment, I'll be honest. It's pissing me off so much. It's... magnetic spin. Oh my goodness. Magnetic moment, not this one. Particle spin can possess magnetic dipole moment, like a rotating electric charge body with classical electrodynamics. Magnetic moments can be experimentally observed in several ways, example with the friction of particles or particle fields, same kind of experiment, or by measuring the electric fields generated by the particles themselves. That's kind of the problem too for me, because it really feels like it all technically stems from charge, but there appears to be a difference between magnetism and electricity. Dipole moments, my arch nemesis. Damn it, I was really hoping you would help me out here. Non-zero magnetic moment. Yeah, right, I know spin now. I know what spin does. I know how it works. So here's the thing, I've been just scripting the video some more. I am going like crazy with this video. At this point, I am right here at the double slit experiment, so on page number 5, and so far I've scripted 7 pages. So I am going hand in hand script and animations, and there isn't really all that much scripting left to do. There is just electricity to explain, magnetism to explain, then the weak force to explain, which won't take that long, and strong force. But strong force I'll explain only extremely briefly, because I'll be honest, I don't find strong force too interesting. Maybe I'm wrong, but to me, strong force isn't interesting, is it? It's just quarks, that's it. Up and down. Create subatomic particles. Nothing exciting. Hi, Path. Hi there, Atomic. Whoa, my goodness, why are you doing this so early, Atomic? You started early on one night, I couldn't sleep. Go to sleep. We're gonna be doing boring nerd shit. We're going to be talking about, like, fundamental... Oh, you donate $5 charity. Alright, time to add the list. Strong force is beautiful with gluons. Is it really? Well, maybe then... That's a maybe. I feel like I should leave the strong force in depth for the elementary particles video. Or maybe one of the elementary particles video. We'll see. There we go, atomic steel, day 1111. I'm so glad I can just copy it over. So convenient. You have donated almost $200. My goodness gracious me, that's a lot of money. That is a lot of money. You're amazing. On my 3-month streak on Cannes. Also great. Oh, I'm trying to be more positive in life, you know? Recently I've been feeling a bit not so great. Oh, let me just pop my vitamins, speaking of. And I feel like it's a mindset issue. I feel like I should just gaslight myself and into being positive again. There we go, alright. How's the animation? Oh, it finished the rendering, how sweet. You were wrong, the answer is both. So the basic idea looks like this. We have this thing called double slit experiment. So a light bulb, a wall with 2 slits, and another wall. So just a wall emerging out the ground. Alright, so that seems simple enough. Like this, there we go. It can be just white with nothing interesting going on. Hi the red blocks. Hi the pseudonym. I think double slit experiment is pretty neat. It is one of my top 10 favorite experiments. It's absolutely love it because it's so rare. I already mentioned before, but it's so rare to find like a proof of something as complex, as seemingly illogical, and as advanced as wave-particle duality with something like as simple as the double slit experiment. Something you can just do by yourself. It's really amazing. Okay, hold on, there we go. What's your top of all-time favorite experiment, make it? I think, well, I might change my mind on this because I don't have a list of my top favorite experiments of all time. I do have a list of top favorite things, but that's unrelated. I think off the top of my head, it would be the light polarization of Bell's theorem. That would probably be it. Light polarization experiment. What is it called? The one with the different polarized. There we go. This one. That's probably my favorite one. Because the thing is, uncertainty principle is such a difficult thing to explain, or rather, is a difficult thing to accept as a leading theory in science. But once you show people the light polarization experiment, this one, it has to make sense, because otherwise it's a wild thing. This is a horror animation. No, it is not. This is animation of light. It is a bit dark, but that's only because soon I'm gonna crank this up. Like so. And then it's not gonna be dark anymore. The thing is, we're talking about light, so for light, I just pick a dark environment with bright things. Hold on, let me fix my microphone first. There we go. I can play my job and how sound travels in water. Waves are awesome. Hydroshot. Experiment equivalence principle is my favorite. If not because it doesn't require any labs. I don't know, thought experiments are fine and all, but I'm not the biggest fan of thought experiments. Simply because, you know, real world experiments just beat thought experiments every single time. Like, if the thing is, if before relativity, or rather if before quantum mechanics came along, you were tasked with imagining something that exists both as a particle and a wave, a thought experiment would tell you that it cannot happen, but a real experiment can tell you that it does happen. So I'm not the biggest fan of thought experiments. They're a bit too flawed for my liking. How do you learn to make your animations? Patience and years of my life. That's how. Alright, let's cut this in half. There we go. And then just 2 slits right here. Hold on, I'll answer some more, but I just need to real quickly. There we go. It won't be quite as visible that there are slits in here, so I guess it should appear like so. Hold on, I'm trying to figure out a clever way to make it happen. I said the thing. So like 30, it should be right here in front of this. Negative 90, and we want it to be in front of the camera. And then right here, I guess, actually, oh my goodness, copy this over here. Then I'm gonna put light behind it to light it up. 260, 60 to 3000, there we go, animation render. Can be easily learned online, or just by doing stuff in Blender, so I did. Walking into a cold lake. Wait, into? Are you okay? That doesn't sound good, does it? No. Building your animation time and patience won't feel burden. Exactly. The thought experiment made general relativity happen. Yeah, but like, but the thing is, thought experiments. This is so bizarre to me that thought experiments are even a thing. The reason why we do experiments is to like verify our thinking, right? Because there are a lot of things which make sense but aren't real. A lot of them. A whole list of things which make perfect sense only to then be proven false later on. So that's why we do experiment. A thought experiment, well, what purpose does it serve? It's a good way to think about stuff, but it's kind of the opposite of why we do experiments in the first place. It shouldn't be called a thought experiment, my point is. Thought experiment gives it credibility that it really shouldn't have, in my opinion. You said the thing. Ah, jeez. Jeez. This be rendering. Well then. So if I understand correctly, actually, hold on. How does a magnetic moment create? You know, how does spin create magnetism? And that's what I'm curious about. That's what I want to know. Spin magnetism. I can't watch a video 12 years ago still, but can't watch a video that's content stealing directly. And I don't condone content stealing. Thought experiment, the most popular when philosophy and natural sciences were not separate. I'm not against thought experiments. I'm just against us calling them experiments because they really aren't. They're just thinking. Thought experiments are just thinking. That's what it's called. Call it thinking. And then my undergraduate versus some others, yeah, okay. Electron is not a spinning ball of charge, and the intrinsic spin particles cannot be understood in such terms. Not only is difficult to make sense of particles being about so much, you electron spinning ball of charge. The value of the ratio between magnetic moment and the angular momentum is a factor of 2 too small. Charged board and magnetic field. Okay, that's not what I'm looking for, but yes, I already knew that. Scientific American. Well, I'm not American. But I am an American at heart, so. Experiments open new doors to unexplained theories. Yeah, but as I mentioned, I don't have a problem with thought experiments. I have a problem with calling them experiment. Yeah, I think we should change the name. Yeah, because this is false credibility in this case. I am all for theories, like general relativity, for example, was an outstanding theory even before it was proven. I have mentioned it time and time and time again, that the Nobel Prize that Einstein got should have been split between Einstein and his dealer, okay? Because the amount of weed, the quality of the weed you need to smoke in order to come up with a theory as wild as general relativity is immeasurable. So, theories can be outstanding. It's just that in science it's extremely important for us to separate between theories and proven. By the way, Atomic, I knew you were gonna donate 12. The second I saw that this was 188, I just knew you were going to donate 12. Okay. I love that I have to manually do it, as if I couldn't just set up a script. 200! Atomic just donated 200 bucks to charity. Well, not just now, but neat, you know. The 200 nation gold and dip to do my maths. Alright, that's ferroatomic. The profile picture fits, so Pevki just joins in, donates 200 bucks, leaves to study maths and refuses to elaborate. Educational Reddit. Oh, you're not familiar with Stack Exchange? Stack Exchange is great. Hold on, that's not what I'm looking for. Libratex, my beloved, okay. So we're gonna spin angular momentum. Actually, my blue nickname, Remco. Remco, I summon thee. Remco, how do spin be creating charge, am I right? How do it happen? I've been summoned as a side effect. Ashad, would you happen to know how spin be creating magnetic stuff? Magnetism. It should be named Atomic's Counterfight. The name is already... I already stole the name from Atomic. Counterbad was Atomic's idea. Which is kind of fitting considering how Atomic donated 200 bucks to it, I suppose. Remco, Ashad, would any of y'all happen to know how spin be doing magnetism? Because I'll be honest, electricity is like essentially a charge in motion, right? It's spinning. Intrinsic or rotational spin? What? Okay, let's assume for a second that I don't know. Or rather, would you mind explaining the difference between intrinsic and rotational spin to anyone watching right now who doesn't know? Not me, I know, I obviously know. I'm smart. I obviously know. Just, you know, in case anyone wouldn't know. Rotational spin. How can a spin? You know what? I don't. Hi, the position. Oh, hi, Kim. Hi, welcome. How you doing? Let me get a sip of coffee. I don't care about spin quantum number. Spin quantum number is kind of obvious, considering if. But that's the one missing piece of the puzzle was the spin. Rotational spin is one of angular momentum. A ball spinning. Rotational spin is a funny property we all love. Oh, then I don't care. It doesn't matter. I just care spin. I just want spin. I don't care which one, I'll be honest. Not much of a difference. We're talking about particles anyway, so I guess intrinsic, but it doesn't really matter. Because that's kind of the one missing piece of the puzzle. Right here, I'm right now scripting the electricity segment, and that would be such a nice segue. Just, you know, having something with charge spinning that create magnetism, and then explain how electrons have spin precisely for that reason, because they just create magnetism. That would just be nice, would be perfect. Would be is the unfortunately operative word, because I don't know if that's how it happens. I don't know if that's how it works. How's the animation going, by the way? It is really dark. I do have to snap a light or something. So, hope poisoning. Hi there, Happy. Having some hope poisoning. Well, I actually had the exact opposite, and I'm just now trying to regain my hope poisoning. Happy Veterans Day to my brothers and arms. Happy Veterans Day, everyone! I don't celebrate stuff, unfortunately, because I just lose track of time so often, but Happy Veterans Day! You're working on spins? Kind of. I'm making a video about all fundamental forces, and electromagnetism is really often divided into electricity and magnetism. And from what I've seen so far, like the spin of electricity causes magnetism. But I don't know how it works. Spin is a spin. I think more state electrons. If a ball spins around, it creates a magnetic moment, which can be seen as if the ball induces an effective magnetic field, as if it had intrinsic spin. Remco, that's so confusing. There's a magnetic moment which can be seen as if the ball induces an effective magnetic field. Alright. Okay, so if something spins around... Okay, you know what? Let me just ask the question that I have and have you all kind of semi-fact check me. If I have a ball, right? A big boy ball like a basketball, except because of some make it. Hold on, let me just. Because of some make it secret formula, all right, that I spilled on this basketball. Okay, this entire basketball has a charge of positive 1e. I know it's not a lot, but it's hey, it wasn't easy to create a basketball for charge. If I take this basketball and if I spin it, is it going to create a magnetic field? The spin direction I just drawn is arbitrary. The point is some sort of spin. Is that going to create a magnetic field? Yes. Okay, that's actually... Okay, cool. Huh. Actually kind of it, to be honest. It's just like all these texts are repulsive towards my brain. If there's any constellation positron... why do I call it positron? Okay. If there's any constellation... I don't know, positron just... Sounds like a Megatron to me from Transformers. It took me months to learn this. Literal months. I am not clever. I cannot stress that enough. I'm not clever. I just pretend. And give me light. If a ball is spinning around its axis, it will do magnety. Great! That's actually good. That's great. Megatron, Transformers era. Depends on its angular momentum, aka rotation speed. That makes so much sense now. Oh my goodness. Okay. Everything clicks in so nicely. It's almost as if science is coherent. Wouldn't you believe it? Well, I only have one problem now, right here. By the way, this is my artist interpretation of what a photon looks like. This. I think it's pretty. No, I get the spin of electrons. I do. We already had that talk with Flame, alright? For so many times, actually. Not once. We had that talk a couple of times. I get that. I just didn't get magnetism. I get it now. Alright, I see. So this is all just one force, except one of them is moving, the other one is spinning. Oh, I see. Oh, that makes so... That's why photons have spin of 1! Oh my goodness! Oh my goodness! Oh! Flame! I get it now! I get it now! I finally understand why photons have a spin of 1. Because it's electromagnetism! It wouldn't make any sense for them to not have a spin of 1! Oh my goodness, it's so obvious now! I don't get it. It's because, like, here's the thing. So spin is like, so spin is there simply because you need an object spinning in order for it to turn its charge to, in quotes, magnetic charge, right? So a charged basketball, that's electricity, but a spinning charged basketball, that's magnetism. The light is electromagnetic means that it will have a spin, not necessarily a spin of 1. Doesn't Photon have a spin of 1? Hold on, let me double check it first, because before I make an absolute fool of myself. Spin, 1 h-bar. Yeah, 1. Photon has a spin of 1. Don't try to gaslight me. But then get you into they get 1. It's because no, it makes sense. Hold on, it makes sense in my brain. Let me just double check it. Spin of half. Okay, it makes so much sense. Look at this. If you have a basketball with charge of 1, right? Then this is like electricity. This is electric force. If you spin it, then it will be magnetic, right? If you have an electron with charge 1e, okay, And then somewhere right here, I don't know if it was even on stream or off stream. I don't even remember at this point. My brain, I'm just got so excited. I read somewhere that its spin is there because it's like half. I don't remember where I read it. But basically, it would have a spin of half because it's like half as magnetic as it is electric. Does that make any sense? Does that make any sense? That the photon would be half as electric as magnetic. Half as magnetic as electric, I mean. And then photon being, you know, a quanta of pure electromagnetism would be just as magnetic as it is electric because it's just a quanta of electromagnetism. It's a ratio of electric magnetic field. Well, in elementary particles it would be, wouldn't it? That's what it's there for, isn't it? Right, because the spin, I kind of get it. I mean, I just want to say this is. I don't know if that's the case. I'm just saying that's probably why it is. I just gonna set up animation. We're gonna look it up right away. But if that is the case, I just wanted to say it before I research to make sure that I have my understanding. If that is the case, then this is so obvious. My goodness, I get it. Wow, I feel like that's meme with now what's his name? I get it now. Oh wow. I know the meme. Exactly, that meme. You get the meme. Wowza, wowza, wowza. I am... I'm at lost words, I'll be honest. Okay, no, we want you to spin the other way. Speaking of spin, am I right? Can't escape it. Negative 180. Negative 180, no, 1,000. There we go. Oh, this makes so much sense. I have a Porsche keyboard, what the heck? I make so much sense. This is incredible. This is incredible. This is already a great live stream. I love it. Graviton has spin too, and is not affect magnetic field, I believe. It exists. Yeah, but when it comes to gravitons, right? No, I know. We'll see. We'll do the research right away. Making our target from a plasma chamber copper cooling. Can you recommend me some better element gas for it? You're gonna use argon for plasma chamber with copper cooling. I don't know much about inorganic chemistry, unfortunately. I'm only at the theoretical level. I only now understood spin finally. Well, I have understood spin for a while. I only now understood the magnetic aspect of spin. I think I can, but hide the lamppost! Plasma chamber. Good gracious me. Piezo to mechanical energy to electrical. I have no idea. As I mentioned, I am not great with inorganic chemistry. We're doing theoretical for now. After we finish with theoretical, after really good with theoretical, then we'll move to inorganic. First, we need to find hold on, let me reread Wikipedia article on spin quantum number. Let me reread it. This would make so much sense. Please let my schizophrenic delusions come to light. Pun intended. I could be hiding in that post. In a year we will get really cool experiments. Less than a year, come on. I've been stuck on theoretical chemistry for what, 4 months now? Oh no, that's not the... Hold on. Hold on, I need to... oh, I already checked Discord, yeah. What's his name? Damn it, how can I... Forgot his name. What is his name? What is his name? It's... Okay, doesn't matter. Hold on. The component of a spin along a specified axis is given a spin magnetic quantum number. Convention remembers. Why MS component spin angular momentum in use to this Planck constant. Parallel interaction ranging from pluses to increments. Yeah, okay. Electron spin. Of course, electron spin is what I'm looking for. Nuclear spin can go and suck it! Angular momentum is quantum number. Solution is Schrödinger's Pauli equation. Angular momentum is according to these numbers with magnetism spin with this. The hydrogen spectrum finds spin up is probably the magnetic moment, which was requisite for the fourth quantum number. The magnetic moment vector of electron spin is given by this. Where is electron charge, m is electron. Okay, yeah, that makes sense, right? Okay, but that's spin quantum number. Now what we need is... Actually, we already have photons open. I know I'm looking it up. Photons! Rest free energy momentum. Don't care. What I care about is obviously spin. Spin angular momentum. Gimme. Photon carries spin which is related to polarization. The to angular momentum of light. The angular momentum of photon has two possible values, the plus h, but they correspond to two possible pure states of circular polarization. Because photons in a light beam may have a mixture of these two values. Linearly polarized beam will act as a composite equivalent. Spin angular momentum of light does not depend on frequency. I was experimenting with. Okay, can we have some more, please? There we go. No, not quite. Spin. Yeah, but like, why? Spin. Instantons am I... That's not a real particle. You're joshing with me. Instantons. That's a particle. Classical solution to equation motion with finite non-zero action. That's another... No, you're just making things up at this point. Bye, Lampos, bye, have a good one. Bye, don't die, please. Please don't die. There is no way Instanton is a real thing. This is basically like the difference between normal particles and... No. Hold on, I first need to double check my walking before presenting to Flame. I just got so excited. Because I found it. Danny DeVito. Yeah, thank you so much. It was Danny DeVito. How come I forgot Danny DeVito? I am... Go on. Hold on. Okay, I'm just... Alright, we need to find the... giving explosive argon thin channel pre-please. I want to see make it mask with really cool, colorful explosives. I do more fire stuff than explosives. Explosives are terrifying. I might do some explosives in the future, maybe. Calling person average is mean. That's pretty good. I'm adding it to best comments. That's pretty funny. There we go. Photons are great too. Photons are awesome. Yeah, okay. We care about the quantum number, correct? Some spicy music without DaVinci Resolve, exactly. Spin quantum numbers may have different values. The direction spins, magnetic spins, and energy particle can change. Charge particles through magnetic dipole energy factor differs from one because context will imply the internal charge and mass distribution differing rotation object. The conventional spin quantum number is 2, okay. Tesla will spin this. The value is in which particle depending on number not be altered in a way. In contrast to the spin from below. The spin angular momentum S of any physical system is quantized. The value of S are these. Complex equation makes sense, whatever. Smash, smash, smash. I am smashing my keyboard because I'm excited. I'm writing and reading Planck's constant. Take on okay. With half-inch spins, fermions, particle with inch spins are bosons. So why would a boson have an inch spin then? That can especially in competitive gaming. This is competitive researching, so you know, practically the same thing. What do I do for discrete arguments? Leptons, okay, don't care about quarks and leptons with all due respect. Carrying forces has been 1. The same quantum state is used in the laser, which is okay. The Graviton, spin 2, Higgs boson, electroweak symmetry breaking of spin 0. Higgs boson of spin 0 has been considered proven to exist. It is first elementary particle, it's in nature. Okay, cool. What about spin of the photon? Such a photon is electron. Okay, alright, cool. What about the photon? Just wondering. Well, photons have integer spin and okay, as an example, electrons have a particle with half-integer spins of electron exclusion spins, but particles with integer spin do not. Doesn't help. Yeah, study. Take care. Bye, Kim, and have fun. Bye. Yeah, tell Lamp to behave and also stop him blowing himself up, if you don't mind. I worry about them from time to time. Anyway, I am so locked in at the moment, as kids these days would say. Okay, so magnetic moment. The value of the transform, yeah. Neutrons on the particle. And the minimally extended small non-zero neutrino masses predicts neutrino magnetic moments of this. Okay. Okay. Yeah, there's a neutrino magnetic moment when neutrino masses, but magnetism, new physics above the electroweak scale of value is going to be higher neutrino magnetic moments. Okay. No, never mind. Damn it, I was wrong. Because it doesn't have a... because it doesn't have charge. Of course it doesn't have charge. Make it, you bloody moron. So it's just because it's a boson? That's it? So it was such a boring explanation. Fine, whatever. I don't like it. It was 2 hours. No, I have a foreseen now. It's something like AM my time zone. I'm so sorry, Hush. What's your day at this hour? It's because I was available. That's why. That's an American time zone, if I'm not mistaken. If I do believe. Your theory holds for spin half particles. Yeah, but it's not. I don't want to Photon. It's not my theory. Not my theory. It's something I read, and I was trying. I thought that photons would have the same reason, but they don't. Of course they don't. How did I not see the electric charge 0 coming? That was so obvious. Actually, it's not 0, it's less than 10. Ah, it still holds. Yeah, 20 cup of coffee. Won't listen much, but I'll try. I understand. After 20 cups, Jesus. I am so upset. No, this is the I don't care. This is the last time I try to get excited about spin. Every single time in past, spin has failed me. Like it. Okay, hold on. Why do photons have a spin of 1? Just ignore spin. Spin doesn't love you. No, spin is like, I'm in a toxic relationship with spin. Why does a photon have spin 1? Exactly. Inappropriate. Primary differential been integer. Well, I know, but like, that's not what I'm looking for. I know they're elementary. I made a video out of it. I'm making. Two degrees freedom polarization which particle. In particular, the circular polarization of photon is characteristic of a massless spin 1 particle. Other spins like 0 or 2 have different polarization patterns. It's just spin. I am so upset. No, I really am. Make it stuck first. No, I'm really like in a toxic relationship with spin. I get excited, I get all worked up, I'm like, oh my goodness, spin! And then just spin slaps me in the face, chops off my arm, and sets me on fire. I'm running off arms at this point. You get the analogy. I'm really successful. I'm in a toxic relationship with spin. I am! I really am! With in toxic relationship with spin. My goodness. Like 10 of the instant on, I don't care for it, I'm upset. Spin. Yeah, right, this is normal spin. I mean, quantum number, of course. Spin of charged particles actually, because it's not charged particle, make it. Goodness. Make it another messages. It's because if you traded the entire plane, electron would undergo a phase shift for about 180, but light would undergo a full 360 phase shift. I'm wrong, maybe. Rotate the entire plane. What do you mean rotate the entire plane? I'm upset. I'm not even rendering anything because I get just so worked up about the spin. I don't care for spin. I don't care for it. It's upset. I hate it. I hate it. freaking spin. Wall with 2 slits and another wall. So now all we need is another wall, which once again be like a second. Spin is so great. Hey, I'm a Photon, I'm spinning. You have an electron makes the entire revolution point when it comes back, it has no phase shift of 180. Oh, but the flame already tried explaining that to me and it didn't make any sense. Kind of by design didn't make any sense. The whole point was that it didn't make any sense. Why? Right here. Why? More like, why do we need spin? I really am in a toxic relationship with spin. I should come back to gravity. Gravity treats me well. Okay. Yeah, explain quantum number. Spin angular momentum of an electron is given by this. Right. Spin quantum number. So we take the spin quantum number, we pop it in, and we get, so if we have a half, right, because that's, yeah, we have a half, that's half times half plus 1, so 1.5 times half, so 0.75, and is the square root include, no, square root isn't, so it's a square root of 75, 0.75 square root times h bar, correct? Unless I'm doing it incorrectly. Hold on. My kind of chemistry channel. That's also pretty funny. The one nice has got your back, while spin is the one you run after don't ever get to. Yeah. Planck's constant. Ah, what happened to my terminal? Python. Print, and that will be, actually no, import math. Print math.sqrt of 0.5 times 0.5 time plus 1, and then this square root times Planck's constant, which is 6.626068. We don't care exactly about. Actually, no, let me just print this. And we got that, right? And that times the Planck's constant. Well, we don't actually care, I guess. Yeah, fair point, that we don't actually care about. In this case, that's 5.7, whatever. Don't care. And the reason why we want this. Is giving up an option here. As defined square number similar to concentration. Well, looks numbers are these. No pain, no gain, no spin. There's a win. I don't like spin. I don't like spin. Give up spin still, yeah. The angel on the shoulder, the devil on the shoulder. No, it's more like an angle on the shoulder. Seeing me get type and hearing it feels so surreal, yeah. This sucks, this sucks, this is awful. It's bloody awful. That's what it is. That's what it is, it's bloody awful. Where's the cheat? That's what most men ask us. That was pretty funny. That was pretty funny. Also gonna post in best comments. There we go. I'm upset. I'm upset. I had such a good last stream that was ruined by spin. I can't quit now. No, I understand spin in electrons. I still should get excited over that part. It's just that photons apparently are different. They suck. Damn it. Spin? Oh, I'll get you one of these days. Is this okay? So yeah, we're magnetic moment. Yeah, okay. So you get the magnetic moment out of the spin. This is awful. I you can go suck it. So magnetic moment is what we care about. I guess I should actually go for LibreText. The combination of string orientation of a magnet or other object or system that exists magnetic field. The electrons are... No, the electrons are fine. I'm letting electrons off the hook this time. It's the photons that I have it for, because... Ooh, I'll show them. It should work out. Exactly. Electrons are very much not spheres. They're a point! That's what's even more confusing. Magnetic field. Magnetic moment of an object and the magnitude of torque which experiences in a given magnetic field. Alright, fine. Let me just script through it. Make it fun. Photons. Have a large amount of these photons together, like this. A huge electric charges. Attracted and dissolve into a kind of electron soup between them, causing some called the metallic bonding. In reality, you also need neutrons, but that's what the next chapter is going to be about. What kind of F? Doesn't matter. Alright, I'm overspin. Okay? What next? Right here, now the particles are trying line up the light bulb, we'd expect particles to go like this. And so right here what we need is we need for the light bulb to light up to like 1,000 or whatever. So right here 160 is going to be a bit of a longer one. And then what we want is we want right here to copy this. Apply the mirror. Actually, don't apply the mirror. Delete these completely. Delete these completely. And then right here, extrude it forward. Like so. And then this will not be visible because this will be a boolean for our next thing, which will be a cube. Out of pies, they're so tasty. You and me both. Yeah, I won't even attempt to understand what's going on there. Now, you will have a boolean in here. A boolean for this. Is that a plane? It might be. Yeah, okay. And the union is what we want. Actually, intersect is what we want. And there we go. This one will disappear. And then this cube will go on like this. And you can light up in the meantime, whatever, see if I care. I do. And then, like this, this one bright. No, that's too bright. Bright 2. No, that's wrong. Bright 3. There we go. Perfect. Brandon the sucker. I am so done. This spin business. What's the topic of the next video though? You mean this one? 4 fundamental forces? Or you mean the video after this one? That will probably be a math video. Probably. Probably a math video, then a different video. I actually would really like to get to the point where I make 4 videos a month. May seem like a lot, but it's not really. 4 videos a month where will be 1 math video, 1 physics video, 1 chemistry video, 1 other video. That would be the ideal point for me. Anyway, what should I do now? Kind of offer 2 videos a week. Oh, that's tempting, but no. You know what, we could go back to SolidWorks. I'm trying to... We could get back to SolidWorks. What should I do? We have a video rendering. I would prefer to script this video off stream, because I would really like to record it and do like a Patreon only preview today. What should we do right now? Video for which the animation we're currently watching will be made for. Oh yeah, this is fundamental forces. This is the first part of the electromagnetism chapter, which is light. It's gonna be light, then electricity, then magnetism. I'm still unclear on how magnetism happens, so... Actually, no, this will be easier. Hypertext. Not switch to tab, a new tab, please. Oh, piss off! Hypertext.org. And to be exact, physics.hypertext.org. Introduction to magnetic dipole moments. Yeah, fine, why not? That's all the short interaction. I'm looking for something a bit more. Moment of the electron. Isn't this the exact chapter? Oh no, it's different. Okay. Got me interested. Is this stream audio off? On for me. Is it really off? Oops. Hi there from me, by the way. Welcome. Hydrogen atom electron circular orbit around the proton. Okay, that's the cringe one, right. The orbital magnetic dipole moment is a measurement of the strength of the magnetic field produced by an orbital angular momentum of an electron. Aha, I see. So you can really think of it as like electricity being something moving in a linear fashion, and magnetism as something rotating. Oh, I think I know why the audio might be off actually. Hold on. Hold on. I had my fan going in the background. I don't want to poison myself. I've been burning a lot of ethanol for warmth recently. That might have been it. It's because Maxwell was. That's so simple then! Oh my goodness gracious. I have been putting off getting into magnetism for such a long time. You mean to tell me it's just electricity? Except spinning. Boy oh boy oh boy. So simple. What to do now? Makes sense, we get it. It really does. It really does. Why should we divide the fundamental force? Well, apparently because we're dividing into linear motion and cyclic motion, or rotational motion. Apparently. Apparently that's it. Which is an odd way to divide it. Because why shouldn't we? Because it's fundamental! Can we stop dividing fundamental forces, please? Or merging them together into electroweak? What's, by the way, electroweak. Electroweak force is such a... Come on. Electroweak interaction. That's BS. Have the balls to commit. Either remove the weak interaction or keep it in there. Don't join into electroweak interaction. Atom was once fundamental. Yeah, and it's not anymore. Pseudonym, dividing a fundamental force is kind of like us knowing damn well that quarks exist and still claiming that atom is fundamental. That's what dividing a fundamental force... That's what dividing electricity into magnetism and electromagnetism into electricity magnetism is. Remove and separate because of the Higgs symmetry breaking. Still, but the weak... What's the weak interaction? Come on. It's like, oh, because apparently decay happened, so we need a whole other interaction for it. Cringe. No, because decay happens. Yeah, right. And decay isn't real. So it sounds like a Pokemon attribute. Of the unification energy or the GE. Wait, GE. Oh no, it's EV. Never mind. After whoops, Giga. We need a whole new interaction for it. To be fair, gravity is... I don't buy it completely. Gravity is such an odd one. Come on, you can't debate me on that. Gravity is such an odd thing in comparison to all the other interactions. Grouping it together with other interactions is truly bizarre. At least to me. Because, for example, we don't have an interaction for mass. Gravity shouldn't be a force. Not only that it shouldn't be a force, no. Here's the thing. When something has a lot of mass, it's more difficult to accelerate, right? That's why even when you have... what's the equation? That's why even when you have... I think these, for example, equations. Is ME mass of the electron, or is it something different? I don't know if it's these or if it's something different. That was probably this. I lose the equation already. What should it be then? No, my point is that, like, for mass, the more massive something is, the more difficult it is to accelerate. But yet we don't really have that as an interaction, do we? The fact that, you know, massive things are more difficult to accelerate. We just take that as a given, apparently. As a property of mass, or that's what mass is. Why shouldn't it be an interaction? Unless that is an interaction, I'm just not aware of it. It's like we're just taking half of the equivalence. That's it. Yeah. The frame. Go to pseudo. Force me a vector. Well, yeah, but the four interactions are kind of... They're kind of like the rules of the universe. And you have the elementary particles, except for bosons. Gravity had charge. We would have a gravitational dipole moment. Yeah. Oh. Hold on, isn't rotation affecting gravity though? Like with spinning black holes, can't you amplify the relativityness of it all? That's a professional scientific term. Isn't a rotating black hole causing even more... What's the called of Lorentz factor? These equations. Oh my goodness, I forgot. Them's equations with the Lorentz factor aren't calling them... I think space and curvature, so yes. So I guess that would be the gravitational dipole moment. It's just that, well, without the dipole, because no charge. Electron spin, so magnetism. Yeah, I mean, apparently that's what it is. Electron spin is literally just magnetism. So, like, okay, so everything that has spin, every elementary particle that has spin, just has spin-like properties, that's it. I hate... No, I'm done with toxic relationship with spin. Also without the moment. Oh yeah, and also without the moment, that's true. So we have a gravitational. Okay, so we have gravity. Cool. Electron flow, electricity. Well, apparently it's just when... It's not really about electron flow with electricity. It's more like charge moving in a linear fashion, that's electricity. Charge spinning, that's magnetism. Gravitational wave! I thought that all black holes rotated very fast. I actually don't know. I don't think they have to. Like, mathematically, I don't think they have to rotate. Is that the angular momentum is conserved, isn't it? I think that was the reason. Hold on. Yeah. I should read. Next month I'll probably make a video on elementary particles. They're really curious. Yeah, it could be fun. Graviton is affected by charge and magnetic should happen. Is intuitive. Graviton is affected by charge, magnetic. What? No, don't. Can we not bring in gravitons anymore? Gravitons. The thing is, gravitons have a pretty serious problem. Now, I've researched it for the video. Gravitons actually have a pretty serious theoretical problem. So it's not really that we're looking for gravitons. That's not the issue. The issue is that we're having trouble renormalizing gravitons in quantum mechanics. So gravitons aren't really just theoretical. The theory itself would have to change for it to be acceptable. It was 100 megabytes. Jeez, what kind of... That's pretty big. 21 minutes of stream, 10 years of school. Yeah. Well, I'm glad it's learned some scientists. Scientists element. Feynman, Dirac. What are those? I've never heard of them. Only because of general relativity are compatible some way or another. If not, we are officially fucked. Well, yeah, but that's the problem, though, isn't it? With gravitons, that's what's so problematic about them. It's not that gravitons are theoretical. Even as a theory, they fail. Like, they are theoretical squared, which is that theoretically, if there is a way to make the theory, then they could exist. If you compare that to photons, that's a massive difference in carrier particles. Theoretically squared is hypothetical. I guess, actually, yeah, I suppose that's fair. No, I would argue that gravitons are... Never mind, yeah, you're right, it's hypothetical. They're basically on the same level as... Oh my goodness, why am I forgetting so many words today? Tachyons. Gravitons are basically on the same level as tachyons. As in, we have a general framework for predicting what would, the world be like with them. It's just, what do you mean, nah? No, they really are. Like, neither of them actually work in our current theories. Gravitons really are on the same level of hypotheticality as tachyons. I mean, Muse in his fan base who couldn't take that joke. And get offended on who's Feynman and Dirac. Oh, that's actually such a good bit for a video. Oh my goodness, Hashi just gave me a great idea for a bit in the video. The same just, just to offend people who don't get the joke. Me, on purpose, acting as if I have no idea who certain people are. Like, this was created by Einstein. This theory, I know, Feynman, Dirac, Maxwell too. Remco went awfully quiet, which means either Remco gave up on me or is writing a long comment on why tachyons are actually much worse than, or why gravitons are much better than tachyons. Remco, I know you're a graviton fanboy, okay? Just sitting there in your I love gravitons shirt and your gravitons are the best cap, slapping your graviton juice. Okay, but I think value of hypothetical acceptance in physics field is also a measure of likability. I'm not saying they're unacceptable, don't get me wrong. I'm not here trying to claim that we should stop pretending like gravitons could exist or something. I'm just here saying that... Oh, hold on, not to make a the beam. Yeah. You're not wrong. Gravitons are required to keep all the physics people sane. No, not physics, quantum physicists. Gravitons are quantum physicists' favorite because if gravitons... Here's the thing, gravitons are like the thing stopping quantum mechanics from being the theory of everything. If it wasn't for gravitons, quantum mechanics would be the best theory. But the sole reason for why relativity is considered cooler than quantum mechanics is because of gravitons. That's it. I have infinite time, exactly. Okay, oh. Here. How's the animation? Still rendering. Almost there, though. Almost there. Tachyons are not real, it's okay. If gravitons are not real, I'm giving up on physics and will do economics or something. Okay, wait, okay, actually why? No. If gravitons aren't real, that means you can't rely solely on quantum mechanics. I guess the true fallout of gravitons not existing. You just have to rely on multiple theories. Einstein just came in and absolutely wrecked quantum mechanics. Particle physics specifically, I think quantum 2 can be considered two fields, field theory and particle physics. There are actually so many more that come into quantum physics than just field theory. There is, there's so much. From particle to nuclear, everything is considered quantum mechanics. Quantum is more like when you quantize something, and that's it. Not necessarily on new theory anyways, we do. I just don't want string theory though to... Okay, maybe a bit of a warm take, but like, I don't want string theory to be the theory of everything. Like, string theory is cool and all, but that's just quantum mechanics 2.0. It's so boring. That's like when, when, you know, a big studio does a sequel, which is the absolute same movie. No, string theory is just quantum mechanics 2.0. I mean, nah, no, it is. It very much is. Quantum loop gravity is quantum mechanics. No, string theory is quantum mechanics 2.0. The idea is the same. String theory is like quantum mechanics 11. Okay, that's fair. And she has done so much physics. Fight. Was a hot take for the physicists. And today I would like to thank you all three fans of the Graviton out there for defending fearlessly. I'll defend my beloved string theory. What an odd thing to defend, Gravitons, really? I'm kind of cringe. You may hear Tachyons though. I don't know, Tachyons are kind of fun. Like, Tachyons are a fun theoretical particle. You know, when it comes to theoretical particles, Tachyons is pretty much as good as it gets. You don't have any theoretical particles that are more fun than Tachyons. All the other ones are either like created for the purpose of equations, or others are just created, you know, because why not? The Tachyons are the ones that are like mathematically, technically maybe possible, but still wild. Giving anti-particle vibes, which is an anti-speed sense. It's not quite anti-speed, is it though? It's imaginary mass. It's the thing. That's the jump though. We don't even have negative mass, and we're asking for imaginary. Also, can we appreciate for a second how a photon can just into nothingness and create an electron, a positron, and we just accept that, you know? Its energy is mirrored. It's flipped, yeah, where like speed of light is the lowest energy it can have. Just wild. Guess where I am. Are you at lampposts? Just wondering. feel attacked. I learned that from a great source. Sites make it. I still believe that was actually a great visualization of how it works. Also, I absolutely love how devilishly simple it is with tachyons. Mainly because they are a theoretical particle, so there isn't really much work to be done there. Like, all the complex things that stem from particles, like, with electrons, for example, the basic idea may seem simple, but then as people do more research into it, then, then they discover more and more things which complicate the electron. When it comes to tachyons, however, they're so simple. We just created imaginary mass, and we pretend it exists. And because of that, you can just do this, and this describes the tachyon perfectly. What the tachyon is. This is just the relativistic energy of a particle. This is the relativistic energy of a particle with imaginary mass. Actually, no, not the relativistic energy. This is the energy required to accelerate mass at velocity, right? So I guess still relativistic energy. What's the difference? Same difference. Actually, I already said that. I'll get back to studying chemistry, but I don't wanna... I'm a sucker for puns! No matter how forced, no matter how stretch of a pun something is, I will laugh. I love them. Pokemon case, what does that mean? Okay, there we go. So we have this. Next we have... Particles. Yes. However, if they were waves, you'd expect them to interfere with each other, and the pattern on the wall would look more like this, and then the, interference pattern. Is imaginary mass highest energy 0? No, it's highest... If I'm not mistaken, if I remember correctly, like, the thing is, the more energy you give something to accelerate, the higher will be its velocity. For tachyons, however, because they have imaginary mass, and because in relativistic equations mass is squared, this will end up causing mass to be negative, and because of that, basically, the more energy you give it, the slower it will get. If you give a tachyon infinite energy, it will just have a speed of light, and then the less energy you give it, the more it will accelerate up to infinity. So, if you have an object at rest, not moving, that's that object with no relativistic energy. If you, however, have an object with no energy, that's a tachyon, so a tachyon with no energy, it will just have infinite velocity. It's hard to picture it, that's why they're hypothetical, right? We haven't seen them, so obviously it's hard to picture it, but that's the beauty of purely theoretical things. Gravitons have more weight to them, because tachyons are just mostly imaginary mass, let's see where it takes us, but gravitons have more like the quantum theory applied to gravity. What if photons are just tachyons with infinite energy? Yeah, actually, good question. Well, what if all of our matter is actually tachyons with imaginary energy? What if? Or rather, negative? No, imaginary. Remco, have you heard of photonic matter, by the way? It's so silly, I absolutely love photonic matter. What if our matter is the dark of dark matter? Yeah. Have you heard of photonic matter? Which is just matter photons. Photonic molecules are formed with individual masses. Photons interact with each other so strongly they act as though they have mass. Which is basically like photons with schizophrenia. This is just schizophrenic photons imagining that they have mass. I absolutely love it. This is why superconductivity... I don't know. I don't think we have an answer for why superconductivity. Researchers drew analogies between phenomenon and fictional lightsaber from Star Wars. Oh, it's great. photonic matter is basically the mechanochemistry of physics. The definition, photons come to the calculation process. It's so silly. You could have a photonic chemistry if you want to. Photons but high. No, this is photons with schizophrenia. This is just photons acting as if they have mass. Like forgetting that they don't, so just acting as if they have because they just interact with each other. Absolutely love it. We have to divide matter into normal matter and dark matter. Why normal matter is normal? Isn't that racist? That is. It's really sad, honestly. We live in a world where some matter is also considered antimatter. Whenever it comes to contact, it just creates. No, I just... Hold on. I'm sending a funny GIF or GIF onto the Flames Chemistry channel because I'm funny. Alright, there we go. When an attacking hits my its remaining energy is transferred to me and goes away with infinite velocity. No, the problem there, real simp, is that basically because of how tachyons work, according to our current theory, at least I don't remember if it's actually consistent, but I have read about one theory where basically because of how tachyons have that level, that speed, that energy, they are actually not only going back in time, but they also cannot interact with anything because of that. So basically, a tachyon, if it goes into your head, it cannot hit it. It just simply cannot. And so that's why this is a whole other problem where, like, you know, our universe could be filled with tachyons, but if we can't interact with them, then are they really real? If nothing interacts with tachyons. There are things smaller than atoms that atoms are made of. Edward! Blasphemy! To the stake with him! Jeff, good pronouns. What is tachyon? Tachyon is it's a hypothetical particle that travels faster than light. Dear strings, Remco, quit spreading your string theory propaganda. Hi there, Zentray. Oh, you thought I wouldn't remember you, did ya? Ah, you thought I've forgotten about you, Zentray, huh? You thought you can change your name, come in here and pretend as if I don't remember ya. Silly goose. So tachyons go back in time. Well, kind of. The problem is basically. Actually, I can. Well, I made a video about the topic. Funny enough, also, funny story, I have made this video. It's the Breaking Physics Using Math video. I made this video, I think a day before Kushgesagt made their own video about tachyons. Or rather, a video which they break about relativity with a segment about tachyons. And so right here, basic idea is you have this, which is the relativistic equation for energy. And so, negative mass. Not quite positron. You can... Oh, Kim, I'm sorry, I'm just used to reading stuff. So you can see that right here... If I paste it in, there we go. This is mc squared divided by this, so on and so forth. And so basically, if you had something going faster than the speed of light, then this would basically be equivalent to mc squared divided by square root of 1 minus velocity squared divided by speed of light. And so if this was faster than the speed of light, then this would be greater than 1. So let's just say it would be mc squared square root of 1 minus, let's say, 1.01. And because of that, we would get mc squared divided by the square root of negative 0.01. Or in other words, mc squared divided by square root of, that's 0.1, correct? I think. Imaginary 0.1. Someone double check me on the math, doesn't matter. The point is, if you have something traveling faster than the speed of light in relativity, you get imaginary energy, which doesn't make much sense. How can energy be imaginary? But then, for the tachyon, basically tachyon has imaginary mass too, which means that if this was a tachyon, then its mass would be imaginary, which means this would just be equivalent to IC squared divided by 0.1 I, in which case we just cancel out the i's and you get c squared divided by 0.1, which means you have normal positive energy. And because of that, for tachyons, they actually not only can travel faster than light, they have to travel faster than light. And their thing is that they just have imaginary mass. How long are the strings? Oh, someone asking the real questions. Imagine the energy, imagine that means going back in time, release energy mass. No. If something with normal mass is traveling faster than the speed of light, it would need imaginary energy. But if it also has imaginary mass, then it can have normal energy. So basically you have, for things which travel faster than the speed of light, if they have normal mass, then the energy has to be imaginary. However, if they have imaginary mass, then the energy can be positive, which means a particle with imaginary mass, the more energy you give it, the more it slows down. And if it has no energy, it's traveling at the speed of light. It's confusing, it's wild, and I love it. Actually, if my girlfriend found the speed of light, she'll become real. I actually used to script my videos in a library. I live near a pretty good library. Well, I stopped doing that for some reason. I should resume that. That probably would be a good way to script videos. Instead of doing it on stream, I can actually go there today. Huh. Didn't think of that. I could just go there and finish the video. Finish scripting it. Make it discussing spin. Atomics just keep sending memes. Libraries for the win. I agree. What if no energy? It goes C. But if give it energy, it will go slow? It makes no sense. No, if it has no energy, then it's C. If you give it energy... Wait, no, did I say that right? No, sorry, infinite energy is C. No, I'm sorry. Infinite energy means speed of light. Any less energy, it will accelerate, actually. Bye, Zentre, bye, have a good one. Okay, what's the next animation? Speaking of... No. If there were waves, you expect them to interfere with each other. I have an old video on the topic, so that's probably would be a convenient thing to link up. This way and... -90. And then this way, and then you give me your y coordinate, and you take that y coordinate. And we want you to just disappear. Bright trans, no, bright 3, new one, like alpha, and alpha just disappear. And 60, and there we go. Patreon Minecraft server when? Patreon one, actually I could set up Patreon Minecraft server. We'll see. Also, Lamp said you're a fanboy. That's for people like you make it. Cool. I believe Minecraft is illegal. Oh yeah, I forgot they made Minecraft illegal. Damn it, shucks. I have a question. Go right ahead, Kim. Plus donation Minecraft server 1. Oh, we could actually do it. $200, that deserves a Minecraft server. I think that would just be my single player one. It might be actually. Well, I could join in every now and then, I guess. Hold on, am I... Oh no, did I not keyframe the... Right here, the focus? I didn't, did I? Of course I didn't. Damn it! Damn it, shucks, duck nubbit. Right here, keyframe it. There we go. There, it wasn't focused, that's why it's a problem. Struggling. I think it sounds like something techie. Is that a hint how they will be made in lab technology? You mean the secret government facility to which I work when I just create tachyons? I mean, you mean like how they could be in the future created? Pfft, maybe, I don't know. How would I know? I'm just a YouTuber guy. I don't work for the. How would that? Why are you asking me? You know what? You should ask yourself. How about we change the topic, okay? Yeah. Tablet in the sink, so no Minecraft windmills. Why did you put a tablet in the sink? The dick move. Probably see it and go the ones of happiness. Actually, I really want to do stuff though. Oh, SolidWorks! That's one thing we could do right now that we're rendering in the background. I actually feel like I've learned a fair bit of how SolidWorks works, you know? Hold on. Starting SolidWorks, however, is a long and dangerous process requiring 3 human sacrifices, so give me a second. I don't make the rules. I just enforce them. Violently. There we go, continue, password. I don't remember me, you won't, anyway. There we go, open it up. Launching SolidWorks, cool. That's right, yeah. Is the stream ending? No, it's not. I'm just opening SolidWorks. I think there's my sailors and I immediately break them. Hold on, part DC motor, there we go. I'm trying to build DC motor, which has a particular gear at the end of it. I'm showing you the gear. Delete the sketch, exactly. So, if I'm not mistaken, we have to go like this, we have to go to sketch, we have to create a new sketch. And in that new sketch, we want to take a line. I said, connected to 3D experience. I don't care. Give me a line. There we go. We have to take a line and we have to make it 1 millimeter long, if I am not mistaken. Actually, no, that's wrong. Shucks, dagnabbit. 0.5 this way. Oh, that's convenient. Well, no, not quite what I'm looking for, actually. End chain. Double click. Double click what? Double click right? Why are you breaking the sailors? Maybe the stream was just a friend who made along the way. Exactly. Fourth time eating pineapple. We used to have wooden ships for Iron Man, now we have iron ships wooden men. What does wooden men even mean? Smart dimensions, move this in relation to this. Can I? May I? Oh no, you're going up. I don't care about going up. No, don't go up. Not up. I mean, like, move the sketch. How can I move the sketch in relation to... Not this! My goodness. Suck it. There! This is actually what I'm looking for. Well, not quite. This in relation... No, wait, no. That's not what I'm looking for either. I am looking for the width of this thing. 50. Yeah, well, I want it to be 50. I want it to be 1. There we go. But does brown C make people brown? I don't think that's a property of C. Okay, now the line. We want it to go up. Oh, what's the... Well, that's the right angle. So that's opposite by hypotenuse, if I'm not mistaken. So that would be 1, the angle, but then we also need the hypotenuse. I don't care. I'm just gonna wing it. So much easier. There we go. Sweet. And then what we want is right here in dimensions. We want the distance between these two, like so, to be also 1. Cool. Neat. Wooden Man sounds like something Stephen Hawking would name his theory. Which is hard too. Okay. How do I move this to the right? Assuming in sketch. Probably is gonna be like tool sketch. Move? Would you look at that? There is just a thing that allows you to move. That doesn't seem like moving, does it? Entities to move. Well, it is, of course. What else do you think I meant? That doesn't seem like moving at all. Move. They catch them on fire when the main spaces get too hot for them. Move this thing, right? Why is it just disappearing when I... whatever. This should be X, correct? I don't know. Is this X? We'll see, I guess. 0.5. Okay, perfect, sweet. Now all I need is to go like so. Features, extrude both base of this thing. Yeah. The other way. 9. Accept. Because it was on 0 thickness geometry. How about you piss off? How about that? Huh? Huh? How about that? How about you piss off? With large bodies of water is the real thing. You mean thalassophobia? You're screaming at? I'm screaming at SolidWorks! It tells me it's gonna result in a 0 surface geometry. And it's wrong. Straight up wrong. What if I extrude it to 9 right here? And then I just... Oh, now you walk! Well, that's festive! Couldn't you walk the other way, though? How am I supposed to move it now? How am I supposed to move it? That's a good question. No, sketch is okay. How am I supposed to move this? Once again, the same problem. How to move. Modify. Find the modify features. Can I just move it back, please? What body count then you? Jeez. If I have an object, if I want to move it back, how would one go about doing such a thing? I'm just curious, you know? Just thinking out loud. Sketch. No, don't care. This. Sketch. No, don't care. I meant this. This sketch. Sketch. Right. Tools. Modify. Oh, and contrary just... Oh my goodness. Can I rotate it though? Ooh, that would be nice. Sketch tools. Rotate. This. Center of rotation. Right here. $180. Okay. Damn it! And that's why I didn't want to do SolidWorks. I'm done. Rendered, sweet. Now all we need is an interference pattern on them waves. It's right here. Want it for flat, like so. Move it up to the slits, like so, like so. And then make it smaller. And then move it forward. And then make it bigger. And then move it even more forward. And then should be goodish enough. Hi DCG, welcome! fair warning, usually when I walk on a shader like this, it crashes my PC. So like a fair warning. If a stream stops all of a sudden, that means my PC crashed. So I'm not here to offer any solutions, I'm just here to let you all know that this usually crashes my PC. Texture coordinate, this into distance actually? Yeah, I think distance. No, separate XYZ. There we go. No, distance. There we go. I just want to move it to the first slit. The reason the channel name to make it because he make it that way. Exactly. Okay, now increase it to like 1,000 just to make things easier for ourselves. This is a 1, this is 0.5 is in the middle, and then 0.43. There we go. Now we'll have another one right here. Will be seemingly the exact same. The only difference being that will be 570. And that will be the other slit. And then if we add them both together, congrats, we have an interference pattern with 2 slits. Isn't this great? Okay. Crash in 5. Yeah, exactly. No, I'm not joking. My PC crashed on 3 different occasions in 3 completely unrelated animations whilst doing this exactly. I'm not finished yet, so it might crash the 4th time, we don't know. In the How Math Becomes Difficult video, in the... oh my goodness, what was the... it was a physics video in which I included this. Well, in the Math Becomes Difficult video, crashed twice on 2 unrelated animations. And also in the chemistry one, the most recent. And in this video on gravity too, oh my goodness, so 4 I guess. Controller. Here you can see the right in red, left one in blue, and both together would look like this. Let's say 10 for now, maybe 20, maybe 500 actually. There, that's nice. And so now we have 1 slit, other slit, and both of them added together. Sweet. Now mix color. We'll just add this one as red, this one as blue. And if we add this as a color, this doesn't quite work. Instead, what we want is we want right here blue, right here white, and then right here red, and this incorrect. I think so, at least. This should be... nope, I screwed it up. Yeah, okay. There's black holes. Spam Control S. Oh, I actually just saved it as a new file, just in case. Because usually when my PC crashes, the file also gets corrupted. So, you know, spamming Control S actually doesn't do much. The file will get corrupted either way. There we go. How am I supposed to make the color then? Right here, what do we want? Oh, this isn't blue. That makes sense, actually. Oh, yeah, right. We want to add 1 to it, correct? Yeah, there we go. Just need to add 1 to it. This should fix it. Should doesn't mean will, but it should. And then this as red. Oh yeah, because we're not adding them. Still, actually. Yeah, still, this is wrong. This should be purely... Oh no, it shouldn't. Okay, so we don't want them to have any... Basically, both of them... Oh, there's a much nicer way to do it, actually. Okay, so... Both under peak would be a 2, in this case. So we want to multiply the bottom one by... -1. And then... If they're 0, that means they're both together. If they're -2... Oh, that's so clever. Okay, so right here... This is from -2, this is 2, and 0 on the right. Which means now what we want is we want to divide them by 4. We want to add them. And we want to divide them by 4. And then we want to add 0.5. If I'm not mistaken. Yes, and then we want to add a color ramp. Like this. And we want it to be from red to blue with white in between. And now we plug into color. It's all blue. Huh. This looks kind of right, although this is white and blue, this is white and red. Never mind, I got it right. Sweet. Cool. That's great. Okay, so basically now we've achieved a wave in which if it's white, that means they're both at each other's peak. And we can also add adding to alpha to make a wave more transparent, which means that right here, if they are white, it's... That's so clever, instead of Obama giving a medal to Obama meme. Yeah, the red is meant to represent the... as you can see, one of them is white and blue. White represents when both waves are overlapping. Blue represents when only this wave is present. The other one is... red. Wait, why are they... Why does this already have the interference? But oh, because the alpha, I'm plugging in the alpha, that makes sense. Never mind, that makes sense. Makes perfect sense. There we go. Red and white, blue and white. Both of them. Sweet. I'm gonna go walking out to those. Bye, Atomic. Bye, have a good one. No, it doesn't feel right. Oh, right, because we want this to be the alpha, don't we? No. We want to add 1 to both. No. Yes. No. Yes. Because this is normalization. If we want to normalize it like this, however, we want to normalize it without the color ramp and without the multiply -1. And then once we normalize like this, then this goes 1, 1, so that's from 0 to 2 on each. When it becomes 0 to 4, we divide by 4 because 0 to 4, then we add a half. We don't need to add a half at the end. There. However, why is this negative on the edges? Ah. I do not know. Yeah, I'm thinking about it incorrectly. Anyway, I think I'm gonna go to... It's been 2 hours. That's a solid live stream. We did a lot. That's good. Good for me. I'm feeling motivated, so I feel like I'm gonna work on this video some more pretty well. Also, I just ate, so it's gonna be a pretty long working on the video session, and I might even script the other video. But for now, I suppose that'll be it. There was a lot of spin frustration, it really was, but spin ended. Spinning. How you go spin yourself out? Ha. Anyway, I suppose for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.